In this section, we'll cover percents. So to start with the definition, percent literally means per 100 or out of 100. So that is percent. We can also say it means divide by 100. That also means out of 100 or per 100 as well. We use this symbol to represent a percent. So if you see the symbol percent, you can replace it with divide by the number 100. They mean the exact same thing. Now, why consider or use percents? An obvious example would be something like with grades. So maybe you take a class and there's an assignment where you get, let's say, a 63 out of 75. So this might be described as the grade you got out of the whole, the number of points you could possibly get. And this as a grade, it's kind of confusing. Is this good? Is it bad? It's easier if you could think about this as something out of 100 or something divided by 100, which is a percent. In fact, 63 over 75 is the same thing as 84 divided by 100. And for this reason, if you received this part out of this whole as a percent, you would say that is 84%. It's pretty good. That would be like a B. So percents are used because they're a little bit conceptually easier to understand. It is a part out of a whole where the whole is 100. Now, percents are also used in studies quite a bit, and here's one I looked up recently. It has been estimated that out of all Americans, 42 million of them like pineapple as a topping on their pizza. Is that a lot of people? One way you could consider this is as a part out of a whole. And I'll assume we're talking about just people living in the United States. I think the population is approximately 350 million people who live in the US. So the part would be 42 million out of the whole, which is 350 million. So here you go. The people who like pineapple as a topping on their pizza is this compared to this. Now, this is quite a bit smaller than 350 million, but I still really don't have a great conceptual understanding of how significant this is. Is this large? Is this really small? Well, I'm going to divide this on my calculator and see what I get. So I'm going to type in these two numbers and see what I get back. The number that I get is 0.12. And if you write this as a fraction whose denominator is 100, that is 12 over 100. And the reason for this is, here's the decimal point on 12. If you divide by 100, it moves 2 places to the left, which gives you 0.12. So this fraction is equal to this fraction here. This one's hard to understand, but this one is definitely a little bit easier. So 12 out of every 100 people like pineapple as a topping on their pizza. And therefore you can say, well, that's 12%. At this point, you could say that's a pretty small percentage of people living in the United States. 50% would be half of the population, 25% would be a quarter, and this is much less than that, well, at least according to this study anyway. One last thing I'll mention on this slide is that 12% is equivalent to 0.12 as a decimal. These two things are the same, and this means if you have a percent, you can write it as a decimal, or if you have a decimal, you can write it as a percent. So in the next examples, we'll look at how to convert back and forth between the two. With the definition of percent in mind, meaning if you see this symbol, you can replace it with divide and then 100. Let's convert all of these percents into their decimal equivalents. Starting in part A, 40% means 40 divided by 100. You even think of it as a fraction, 40 over 100 if you'd like to. The decimal point on 40 is here, and if you divide by 100, you'll move it 2 places to the left, and therefore, this is equal to 0.4. For a little emphasis, you could put a 0 at the end if you'd like, but the main idea is, if you see percent and you divide by 100, you can move the decimal point a total of 2 places. How will that change here in part B, 4% as opposed to 40%? So we are still taking 4 and dividing it by 100, or as a fraction, 4 over 100. If the decimal point is here and you move it 2 places to the left, it's not going to be 0.4, it's going to be 0.04. So that is we have 0.04 as our answer. It is a common mistake if you have a single digit to write 4% as 0.4, when in fact you'd write it as 0.04. In part C, we have 2.75%, and again, this is 2.75 divided by 100. In fact, at this stage, I think what we can say is it'll move the decimal 1, 2 places. There'll be a 0 here and a decimal point to the left of it. So this is equal to 0.0275. And for part D, here we have a fraction, so 1/5%. You could write this as 1/5 divided by 100. If we could change 1/5 into a decimal, then we could just move the decimal point 2 places to the left on the number 1/5. This can be done in a calculator. 5 goes into 1 0 times, but it goes into 10 twice, and therefore 1/5 as a decimal is equal to 0.2. So this problem is really 0.2 divided by 100. And therefore, you're moving the decimal point 1, 2 places. It'll be 0.002. I'll write the answer as 0.002. So it started here and moved 2 places to the left. So there we go. If you have a percent and you want to write a decimal, we can move the decimal point 2 places to the left. Well, what happens if we start with a decimal and we want to go back to a percent? In example 2, we have decimals that we're going to convert into percents, and we will round our answers to the nearest hundredth if that's necessary. So let's start with 0.75. What is that equal to as a percent? Well, if you start with this number and you want to go to a percent, you won't divide by 100, but you'll do the inverse. You'll multiply by 100. So for the first one, we take 0.75 and we multiply by 100. In doing so, we'll move the decimal point 2 places to the right because the number must get bigger. Therefore, we have 75, and at the end, we'll put on the symbol percent. I know this process works because if you want to convert this percent back to a decimal, you would take the decimal and move it 2 places to the left, giving you 0.75. Let's try that for part B, 0.0003. Same idea. You want to take this number and multiply it by 100. What that will do is take the decimal, move it 2 places this way, and the number we get back is 0.03, but this is now a percent. This percent is equivalent to this decimal. Now, what about the number 7? Same thing works. You can say, okay, I'll take 7, multiply it by 100. The decimal is currently here. If you move it twice, there's going to be 2 zeros after the 7, which is 700, and that is a percent. It is possible for a percent to be greater than 100%, and we'll see an example of that later in this lesson. For the last part, part D, I'd like to write 1/80th as a percent. So that would be, we take the fraction 1/80 and we multiply it by 100. We could get this number as a decimal and then just move the decimal point. I think I'm going to try to write this as a single fraction first. That is, this is 1/80 times 100/1. When you multiply two fractions together, you can multiply the numerators and multiply the denominators. And so we get 100/80. We can simplify this by a factor of 10. This is equal to 10/8. And we can also divide by 2, so we get 5/4. So you could think of this as 5/4%. I'm actually going to divide 5/4 in my calculator. That is 1.25, so you could express it as a decimal 2, and this is rounded out to the hundredth, 2 decimal places. So here you go. This would be one way to convert this into a corresponding percent. A second approach would be to, in a calculator, take the number 1 and divide it by 80 and see what this decimal is equal to. It is equal to 0.0125. If you multiply this by 100, it'll move the decimal point 2 places to here, and that would become 1.25%, which is the same as the answer that we have here. The only thing to look out for is if you divide a fraction, sometimes the decimal will continue on forever. So you just want to make sure you would include enough decimal places so that when you round to the nearest hundredth, it would be correct. In example 3, we'll look at a practical application of percentages, that of sales tax. This one says, let's say you record music as a hobby, and you really want to buy a nice microphone to improve the quality of your recordings. And the one you want to buy is a large diaphragm tube condenser microphone, and it retails for $7,495. Okay, in Massachusetts, the sales tax is 6.25%. So how much will you have to pay for this microphone overall? Now, the way this works is you can take the sale price, $7,495, and you would multiply it by 6.25%. Now, this won't be the total cost of the microphone. This will just tell you how much tax you're paying on it. To do this computation, we have to express this percent as a decimal. That means we divide by 100 or move the decimal place over 2 places to the left. If we just jot down the numbers, that's 7,495. That's the cost of the microphone. If you move the decimal on 6.25, that's 0.0625. Here, if we moved it back to the right, it would be back to the number that appears here. Whatever this product is going to be the tax that you're paying, specifically the sales tax. So I'll type that into my calculator, multiply by 0.0625, and I'll round to 2 decimal places. This value is equal to 468 points, and I get 4375. Since we're talking about a dollar amount, we should round to the nearest cent. So that means the answer is in dollars, $468.44. And that's just the tax. You probably could buy a really great microphone for just this amount of money, the tax alone. Now, is that the total cost overall? And the answer is no. This is just the tax. What we have to do is go back to this price and add the tax back in. So the total cost will take $7,495. To that, we will add $468.44. And when we add this up, okay, carry the 3, that is 16, carry the 1, 9, $7,963.44. So it's better be a good microphone, but that's how much you would have to pay. A few things before moving on. This was a 2-step process. There is a way you can do this in a single step. And to show you how that works, I'm going to look over here. If you multiply the price by the tax, it'll tell you, or the percent, the sales tax, it'll tell you the amount in tax that you're going to pay. And that's this number here. You can alter this expression slightly to take you directly to this answer here. And it's a very simple thing to do. You can change this 0 into the number 1. So you would do 7,495 times 1.0625. The reason this will give you the correct final answer is putting a 1 here means you're going to get 1 times this value, which is this thing. You then multiply this by just the 0.0625, which is this amount, and it will automatically add those two things back together. Let's just try that out. So that is 7,495, and here we're going to multiply it by 1.0625. So let's check that out in the calculator. 7,495 times 1.0625, and rounded to the nearest hundredth or the nearest cent, that is 7,963.44. It actually is the same number. So again, why did this work? The reason this works is, here's the cost of the microphone. And really, when you write 1.0625, you're saying 1 plus 0.0625. I mean, clearly the sum of these two things is equal to this. But you would use the distributive property. You would take this number and multiply it to the 1. That gives you this thing here. You then take this and multiply it to this value here, which is equal to this. And then the two things would be summed together to give you this final answer, this thing here. In either case, in one step, you can get to either the sales tax or the final cost overall. Now, before moving on, I want to look at a variation of this problem, which I'll put at the bottom of this slide. For example 3, we were given the cost before sales tax, and we solved for the price afterwards. You can also do this problem in reverse. You can be given the amount that you pay in full, and you can be asked to solve for the price before sales tax. So this is a new problem that we're working on here, so we'll have some different numbers. Let's say the cost after sales tax is $5,200. So again, this is just a new value that I made up. If this was the cost after sales tax, what is the price before sales tax? Something that can be very helpful in solving a problem like this is using a variable. So I'm going to let the letter P represent the price before sales tax. It's some number. I don't know what it is, but I know I want to solve for it. If you take this price and you multiply it by 1.0625, it'll give you the final sales price, which in this case, we changed it to $5,200. So as an equation, you would take the price P, you would multiply it by 1.0625, and your final answer should be $5,200. So it's backwards. In the first part, I had this number, I multiplied it by this to get the final answer. Here, we're looking for this number, and it should be equal to this amount. How do I actually solve for the sales price? If you're multiplying it by 1.0625, you can divide both sides of this equation by this number to solve for P. So essentially, I'm going to take both sides of my equation and divide by 1.0625. On the left-hand side, they cancel, which is great because it leaves me with P, the thing I'm trying to solve for, the price. This, I think I'll do directly in a calculator. That's 5,200 divided by 1.0625. I'll have to round to the nearest cent, but the dollar amount I get is $4,894.12. So here, this is the cost before tax. If you take this number and you multiply it by 1.0625, it'll give you $5,200. So here a variable is helpful. It wasn't absolutely necessary in the first part, but we can now solve this problem in both directions. The last definitions we'll consider in this lesson are percent increase and also percent decrease, and they're very similar to each other. They are the difference between the final value and initial value of some amount, but we express it as a percent. So as an example, let's say you invest $5,000 into some account. And then after the course of a year, so we'll say after 1 year, the account grows in value. And let's say that value it grows to is $5,100. So the dollar amount increase is $100. Now this is not a percent increase, this is a dollar amount increase. What does it mean to say, well, what percent did this increase by? How could I figure out that? According to this definition, the question we're asking is, what percent of $5,000 equals a $100 increase? So what percent do I multiply 5,000 by in order to equal 100? You somehow want to make 500 become 100 by multiplying this by some percent. Now, the percent is the thing I don't know. Again, here using a variable could be helpful. For percent, I guess I could also use the letter P for the percent I'm solving for. So as an equation, what we're saying is take $5,000 and multiply it by some percent, and that will produce $100. So here, it's the percent that equals the increase. If you're looking to solve for the percent, you would have to divide both sides by 5,000 to get this thing by itself. So what I'll do is take both sides of this equation and divide by 5,000. On the left, the 5,000s cancel, and we're just left with the variable p. On the other side, we have 100 divided by 5,000, and that is equal to 0.02. This is a decimal. We have to express it as a percent by moving the decimal 2 places because we multiply it by 100, and this is 2%. So by what percent did 5,000 grow? 2%. 5,000 increased by $100, but that's the same thing as saying a 2% increase. And the reason is if you take 2% of $5,000, it'll equal 100, the increase. Now let's try a percent decrease just to see how that compares. But let's use a similar type of problem. So you invest, we'll stick with the $5,000, and then we'll say after a year, the new value is $3,200. So here there is a decrease. Now the actual decrease, the dollar amount decrease is $1,800. Notice that that is pretty significant. I'm anticipating the percent decrease will also be significant as well. So how do you compute the percent decrease? What we do is we multiply $5,000 by some percent and set it equal to the decrease. As an equation, that is 5,000 times some percent that is equal to $1,800. To solve for the percent, we can divide both sides by 1,000. By 5,000. So I divide by 5,000 and 5,000. I'm doing the same thing to both sides of my equation. On the left, the 5,000s cancel. We're left with the percent. That's 1,800 divided by 5,000. That is 0.36. And this is not a percent. We have to make it one. That is equal to 36%. That is a 36% decrease. And maybe going back up here, we could have said a 2% increase. That is very significant. Here, 2%, yeah, the account didn't grow by much, so therefore it's a small percent. Here, this was a significant drop. In fact, you could say it decreased by 36%. While we're at it, maybe we'll just try one more. Put that over here. Same question. Let's say you invest, again, $5,000, and after a year, let's say it grows to $15,000. So this great return on your investment, by what percent did this grow by? And it's the same exact question. You multiply 5,000 by some percent, and you want to set it equal to the increase. If you start 5,000 and you end at 15,000, the increase, the money that you made, the actual increase is $10,000. And therefore, your equation is going to be, for the percent increase, we take 5,000, multiply it by some percent, and set it equal to 10,000. We'd still divide both sides by 5,000, doing the same thing to both sides. It'll still cancel on the left, leaving us with the percent. And 10,000 divided by 5,000 is 2. Now, is that 2%? It's not. This is the decimal that we have to change into a percent. The value that we got here wasn't, and in both cases, we changed it to a percent. We still have to do that for this problem here. In fact, I would not expect a $10,000 increase to be only 2%. It's got to be a lot bigger than that. If you move this decimal twice, the percent that you get is 200%. So it is possible to have percentages that are greater than 100%, and they show up with percent increase. If you more than double your investment, your percent increase will go over 100%. And for our last example, example 4, let's say you didn't buy that large diaphragm tube condenser microphone, the one that retailed for $7,495. Unfortunately, due to inflation, a year later, this is the new price of the microphone. It went up to $9,225. So that's too bad. But the question is, by what percent did the price increase? So we need to know the difference between the final amount and the initial amount. So we have that $9,225. This was the final cost or the final amount. And then $7,495 was the starting amount or initial amount. And what we want to do is subtract these two things to find the difference. And okay, we get this. That's really 11, and that's this. So 0, 3, 7, 1. So the difference is $1,730. The question we're trying to ask is, what percent of the initial amount will yield an increase of $1,730? I'm going to let P equal the percent increase, in this case, that we're solving for. In an equation, we take the initial amount, so that was $7,495. We are multiplying it by the percent increase that we're solving for, and we're setting it equal to the difference, which in this case is $1,730. In order to solve for P, I need to divide both sides by the initial amount. So I'll divide this side by $7,495 and do the same thing over here. On the left, division will cancel that multiplication and simply leave us with the variable P. On the other side, 1730 divided by 7495 is 0.2. Well, there's a lot of decimals, so 230820547. Those are all that appear on my calculator. But we need to convert this thing into a percent, so I have to move this 2 places. And in doing so, we end up with a percent increase that is 23.082057%. It says to round this to 2 decimal places, which is here, and therefore I can simply write the final answer as 23.08%. It is this percent, when multiplied to the initial amount, will yield an increase of $1,730.